Okay, these are the solutions to the even-numbered problems in the Chapter 6 review, which was page 319 to 322, numbers 9 through 48, multiples of 3. If you have not already completed this assignment, stop the video, complete it, and then come back to check your answers against the solutions. Alright, so the first even problem assigned was number 12. And by the way, you should have your textbook open while we're going through these, because I'm not going to write down every single problem, but I will refer to the problem from the book. So you should have your book open at the same time. Number 12, the directions say express each ratio as a fraction in simplest form. And number 12 says 18 ounces to 3 cups. So let's start off with the ratio with the units. 18 ounces to 3 cups. Okay, and remember with ratios, we really want them to have the same units if possible. And since ounces and cups are both units of liquid measurement, we can actually change these so that they have the same units. So you may want to flip to the chart at the back of your book to see what the conversions are. And in the back of the book, it says that 1 cup is equal to 8 ounces. So if I want to cancel out the cups in the denominator, I will put 1 cup in the numerator and 8 ounces in the denominator. And notice what happens here is exactly what we want. The cups and the cups cancel, and the ounces cancel, and we're left with a ratio that just has numbers. That's what we want, because if we had the same units, we'd have units on the top that are the same as units on the bottom. So now if we just multiply straight across the top, 18 times 1 is 18, and 3 times 8 is 24. So our ratio is 18 to 24. However, we want it in simplest form. So we can divide the numerator and denominator both by 6, so we can reduce this to 3 over 4, or a ratio of 3 to 4. Okay, the next even numbered problem is number 18. Number 18 says an 8-pack of juice boxes costs $4.79 and a 12-pack of juice boxes costs $6.59. Which is a better buy? Explain. Okay, so in order to compare, remember the lesson that we did with the goldfish? In order to compare these, we would need to know what the cost is per juice box so that we can compare those two rates. So we have an 8-pack that is sold for $4.79, and a 12-pack that is being sold for $6.59. So let's find a unit rate for each of these. So for the 8-pack, we have $4.79 divided by 8. And remember, to get this to a unit rate, we want this to have a denominator of 1. So we are dividing by 8 in the numerator and the denominator. And then 479 divided by 8, rounded to the nearest hundredth because we're talking about money, so we want it rounded to the nearest cent. This would be $0.60. Let's do the same thing for the 12-pack. There's $6.59 for 12, but we want this to have a denominator of 1. So to get from 12 to 1, we divide by 12. So to get from $6.59 to whatever this is, we'll also divide by 12. And $6.59 divided by 12 is about $0.55. So the question asks us which one is a better deal. Well, I don't know about you, but I would rather pay $0.55 than pay $0.60. So the 12-pack is a better deal. because it costs less per juice box. Okay. The next even numbered problem is number 24. The directions for number 24 say complete each conversion, round to the nearest hundred. And number 24 says we want to find what 12 ounces is approximately equal to in gallons. So just like we did for number 12, you may want to look back in the back of your book to get the correct conversion factors for ounces to gallons. And you'll find that there's not a single conversion that goes from ounces to gallons, so you're going to have to use a few of them. So since this isn't a rate, but we do still want it written as a fraction, we'll just put it over 1. Now the first conversion that I see in the back of the book that will start to get me from ounces to gallons is one that says that 1 cup is equal to 8 ounces. So since we want to cancel out the ounces in the numerator, we'll make sure we have ounces in the denominator, so that these will cancel, and 8 ounces is equal to 1 cup. Okay. The next conversion I see that will help us get there, so now we're in cups, we need to get to gallons. The next one we have says that 1 pint is equal to 2 cups. So again, we want to cancel the cups in the numerator, so I'll make sure that cups is in the denominator. So there's cups that will cancel, and 2 cups is equal to 1 pint. Okay, the next conversion that will help us out says that 1 quart is equal to 2 pints. So pints in the numerator, I need pints in the denominator. And 2 pints is equal to 1 quart. Okay, one last conversion. Now the one we need says that 1 gallon is equal to 4 quarts. So we want to cancel out the quarts in the numerator, so we'll put the 4 quarts in the denominator and 1 gallon in the numerator. Now all we need to do is multiply straight across the top and straight across the bottom. So 12 times 1 times 1 times 1 times 1 is just 12. And our units on the top are gallons. And in the denominator, 1 times 8 times 2 times 2 times 4 is 128. Well, this number right here, we actually want as a decimal. We want a whole number that represents the number of gallons, not 12 gallons divided by 128. So let's go ahead and divide these. And 12 divided by 128 says to round to the nearest hundred is approximately 0.09 gallons. Alright. The next even problem is number 30. And the directions for number 30 just say solve each proportion. And the proportion for number 30, it says 15 over A is equal to 5 over 4. And of course we solve proportions using cross products. So we start with the one that has the variable. A times 5 is 5A. And then the other one, 4 times 15 is 60. And of course, to finish solving this, we want to get rid of the 5, so we'll divide both sides by 5. we get a is equal to 60 divided by 5 is 12. And the next odd numbered problem is number 36. The directions for number 36 say on the scale drawing of a museum, the scale is 0.5 inches. 0.5 inches equals 10 feet. Oops. Find the actual length of each gallery. So for number 36, we're looking in the table at number 36 where it says Renaissance, and the drawing length is 4.25 inches. Alright, so remember in scale drawings, the scale gives you the ratio of the length in the drawing to the length in the actual object. So if we know the length in the drawing is 4.25 inches, we're looking for the actual length. And because these are proportional, we can set up a proportion. So we know that the scale says 0.5 inches is equal to 10 feet. Well, I want to know what 4.25 inches is equal to. And because this is inches, I want it lined up directly across from the other units in inches. Directly across, not diagonal, directly across. So 4.25 inches for some number of feet. Okay, and now we just have a proportion, so we can use cross products to solve. So here we have 0.5 times x, or just 0.5x. And here we have 4.25 times 10. And that is, when we multiply those, it's 42.5. And of course, to get x by itself, we'll divide by 0.5. And then x equals 4.25 divided by 0.5 is 8.5. And our units were in feet, x feet, so 8.5 feet. Okay, the next odd numbered problem is number 42. Or even numbered problem, number 42. The directions say to find the vertices of each figure after a dilation with the given scale factor, k, centered about the origin. Then graph the original image and the dilation. So the original coordinates on number 42 are w at -3, 0, x at 2, 6, y at 6, 2, and z at 2, -2. And our scale factor is equal to 2/3. Okay. Now, if you recall with scale factor, when you're talking about a dilation, the scale factor can simply be multiplied by each of the coordinates, the x and y coordinates, to determine the new, the coordinates of the image. So we'll take the original coordinates of w, and to create w prime, we want to multiply 2/3 times -3, and 2/3 times 0. So that will give us coordinates of 2/3 times -3 is -2, and 2/3 times 0, of course, is just 0. We'll do the same thing for x. To get the coordinates of x prime, we'll do 2/3 times 2, and 2/3 times 6. When we multiply those, 2/3 times 2, this comes out to 4/3. And then 2/3 times 6 is 4. For the coordinates of y, do the same thing. 2/3 times 6, 2/3 times 2, 2/3 times 6 is 4, 2/3 times 2 is 4/3, and z. This is 2/3 times 2, and 2/3 times -2. So 2/3 times 2 is 4/3, and 2/3 times -2 is -4/3. Okay, and now we need to go ahead and plot the original points and plot the new points so that we have a graph of the original image and a graph of the dilation. So let's start with the original points. W is at -3, 0. So there's W. X is at 2, 6. There's X. Y is at 6, 2. There's Y, and Z at 2, -2. Okay, so there's the original image. And now let's graph the dilation. So W is at -2, 0. There's W prime. And to graph X prime, we need to know what 4/3 is, because this doesn't automatically tell me exactly where to go on the graph. So since this 4/3 shows up a few different places, let's change 4/3 to a mixed number. So 3 goes into 4 once, 1 remainder, so 1 1/3. Okay, that's much easier. Now what I'm plotting is 1 1/3, 4. So I'm not going to be exact here, but I can be close enough. So 1 1/3, so right about here, and then up 1, 2, 3, 4. It may not be perfect, but it should be very close. Okay, and for Y prime, we want 4 4/3, or 4 and 1 1/3. So 1 and about 1/3, would be about right there. And Z, 1 1/3, -1 1/3. So 1 1/3, -1 1/3. Okay, so the original image is the larger one, the dilation is the smaller one. Okay, last one, number 48. Number 48 says, the largest known pyramid is the Pyramid of Khufu. At a certain time of day, a vertical yardstick casts a shadow 1.5 feet long, and the pyramid casts a shadow 241 feet long. How tall is the pyramid? Okay, so I'm not even going to try to draw a pyramid, but you have the pyramid, and we do not know how high it is. We do, however, know that it casts a shadow that is 241 feet long. At the same time, we have a yardstick, and since this is in feet, and the length of the shadow of the yardstick is also in feet, let's go ahead and change this so that we're not talking about 1 yard, but actually talking about 3 feet. So the yardstick casts a shadow 1.5 feet long. So we don't know the height of the pyramid, that's what we're looking for, but its shadow is 241 feet long. At the same time, a yardstick, or a stick that's 3 feet long, casts a shadow that's 1.5 feet long. So with these, we will always set up proportions to solve them. So we'll call this x. So x over 241, x over 241 equals 3 over 1.5. Okay, and we'll use cross products to solve. So cross multiply here, this is 1.5x. And then cross multiply here, 3 times 241 is 723. And then to solve for x, we want to divide both sides by 1.5. So we should be getting x is equal to 482. And because we were looking for the height and all of our units are in feet, this is 482